Hey everybody, I'm Dawn Zoldai, and welcome back to the Dawn of Drones podcast. We are rounding out an incredible month that we've dedicated to this theme of support to multi-domain operations, sponsored by Matrix Space. And we have with us two incredible guests today as part of the ModalAI series. We've got Chad Sweet with us again, the CEO and co-founder of ModalAI. And then for the first time, we've got Dev Singh. He's the Vice President of Business Development and the Head of Industrial Automation for Qualcomm Technology. So welcome to both of you.
Thank you.
Thank you, Don. Pleasure to be here.
Well, I'm going to start with you, Dev, because you're new to the show. So tell us a little bit about yourself.
Well, I'm Dev Singh. I lead the business for robotics, drones, intelligent machines, and overall industrial automation as well. It's been a great journey. I mean, Chad and I worked together on drones here at Qualcomm, and before he went and formed the ModalAI. Drones was an R&D thing. We took it and made it a commercial business line, and I run that today, and it's a very profitable and a successful franchisee. But more importantly, it is solving a lot of great problems. So we are super proud to be working on these technologies.
Well, thanks so much for being here. And Chad, over to you. Tell us a little bit about your background, and then we'll get into your long-standing relationship with Qualcomm and Dev.
Yeah, sure. Thank you. And thanks for having me. Let's see. Yeah. So as Dev mentioned, we worked together. Dev was the business. He ran the business, and I was on the R&D side. And we started working on drones at Qualcomm, I'd say in like 2012 or 2013. And we'll touch on this a bit later, but one of the projects that came out of that was the Snapdragon Flight, or now we're supposed to call it Qualcomm Flight, but then it was called Snapdragon Flight. And so we took that foundation and in 2018 founded ModalAI with great collaboration with Qualcomm, tremendous collaboration with Qualcomm. They really enabled us significantly in the early years. And we somewhat extended that into a product line we call VOXL, VOXL, and we continued to evolve that. We're now on the latest chipset from Qualcomm and still kind of keeping that lineage alive, and we've built quite a good business around that, and we're working with hundreds of partners today to go deploy new and interesting use cases.
Well, awesome. And as Dev said, your relationship has been longstanding. I think we have a cool picture of you guys is this back in the day here or what?
That's actually looks like from the Qualcomm Flight RB5 launch.
Yeah.
Awesome. We're going to talk about that here shortly, but you both were involved in such incredible projects together, including the Ingenuity Helicopter. Tell us about that.
Well, yeah, so the Snapdragon Flight platform, it would still be really pretty competitive today, quite frankly, but at the time it was a lot of computing power in a very small and lightweight package, which of course is of great benefit to anything fighting gravity, like drones on Earth, but NASA JPL found that to be also truly beneficial for trying to do a lot of compute to fight gravity on Mars. So they use it as their visual navigation computer, which is like pretty much what it was built to go do. So that's really cool. And I know, and I think they just celebrated the 50th flight over a 2-year period. Dave, do you have more to add there?
Absolutely. I mean, that's one of our underscoring our technology capabilities, right? So NASA JPL chose this platform because they needed something that's powerful, lightweight, and which could withstand all the G forces and radiation testing. The great news here is this is a commercial off the shelf. We didn't do any modification to do this, and it's still working. It was supposed to be a technology demonstrator and do only 5 flights, and today it's a fully commissioned mission and still going on. So super proud, and also talks about the technology achievements that we have and how we are able to benefit humanity and science.
Well, I'll tell you, gentlemen, I was just at the Space Symposium here in Colorado Springs last week, and the nexus between what you all do, I mean, this Mars Ingenuity helicopter and the connection of this commercial off-the-shelf technology is one great example of that. But so many connections between, of course, the drone and robotics industry and space. I would love to see these industries talking more. I'm walking around the expo hall floor like, wow, I should be connecting this company with this company, and just amazing. So that's so exciting that you've been involved with NASA and that incredible journey for the past 50 flights. That is amazing. By the way, everybody, we are live, and I want to acknowledge there's a couple people already jumping into the chat. So we've got Matthew Borowski saying, good morning, all. So hello, Matthew, and Brandon Pfluger. JD, which is Juris Doctorate. For those who don't know, that means he's got a law degree. Looking forward to it, y'all. So, and saying hello to both of you. So thank you so much. Keep the comments coming. We love that. So very good. I want to kind of talk about that. This whole idea of your technology is so robust, including Dev, to foot stomp this. I don't know if people miss that, but the fact that on Mars, there's a lot, not only fighting gravity, but like radiation, and your products can be used up there, which is unbelievable. Let's bring it back down to earth, literally, and talk about the landscape a little bit of the drone industry, because the two of you together are enabling such incredible use cases. And so I'm going to pivot to you first, Chad. And I want to ask this question, and then we're going to talk about the use cases. The first question is, why for commercial drones is smaller and smarter safer? Like, why is that so key to this industry?
Oh yeah, absolutely. It's still like the mission is the same, to compress all of that computing power into something small and lightweight, because it takes a lot of energy just to get off the ground. And so when, prior to the work that we've done, there was a lot of off-the-shelf components bundled together. There were, say, LiDARs and real sense cameras and Intel NUCs and so forth, adding, kilograms of weight just to go pursue advanced functionality. And so what Qualcomm's done over the last 30 years is compress what effectively are supercomputers and put them in your pocket. And so at ModalAI, what we do is we try to unleash that, or harness that capability and make it applicable for unmanned aerial systems.
Well, and I know one of those use cases, Chad, you and I have talked about this a bit, but I love this use case with Clio Robotics, because not only are they doing incredible things on the commercial industrial side, but also on the military side of the fence. Indoor asset inspection, as an example. There we go. There's their little dronut. I mean, who doesn't love a dronut, right? So this is a gif of that. But your combined technology is enabling those kind of flights in really tight spaces that are safe. So, I'm gonna throw this out to either one of you. I want to talk about these fundamental components to fully enable autonomous flights, and not just flights, right? This is multi-domain operations month. So we're talking autonomous operations in the air, on the ground, and theoretically also, right, in the maritime environment. What are the three key components that really enable those kind of autonomous operations? Dev, maybe you're the guy for this.
Yeah, and I'll try to unpack on the previous question and also address this one. So the weight has been very important in drones, specifically because we talked about smaller, safer. All this is a process where you need a lot of horsepower in silicon and all the technology to be able to make sure there's an autonomous flight possible. So for that, in past, like Chad alluded, it was done with a bag of chips, literally.
Right.
And what Qualcomm does the same thing is on a single SoC, which we call system on chip, which is very important to note, because it's like you alluded just now, it's not one component to make flight happen. It's multimodal stuff, right? There's sensing, and we talk about it, sensing, acting and perception and all of this, right? And together taking decisions. So it's the camera perception, there's processing using the CPU, there is again a lot of decision making real time to avoid obstacles and few other things, path planning. So for all of that, you need a lot of horsepower, and it's not just a single kind of horsepower. It's not, everything is not a CPU centric horsepower. You need CPU, you need the camera processing, you need to be able to process the pixels in the GPU as well, make real-time flight on a DSP. So it, even if the processor's main operating system crashes, you have a secondary safety element to it. So all of this, a lot goes on to make autonomous flight happen, and it needs this thing what we call is a hex, almost like a heterogeneous compute platform. It cannot be just CPU. You need CPU, GPU, DSP, and that's what we bring in at Qualcomm, and that's what is needed for a phone, because you have cameras, you have processing, you have audio, and we have all the sensors. In the drone is the same thing. And imagine all of this, and now you can do this with a server class chip too, but then you'll have to cool it down, you'll have to put a heat sink on it, and that would, a Clio would never have been born if you put a heat sink, you make it clunky, and it could not do what it's doing, because it's doing what it's doing because of the size it is, the weight it is at. It's because of the processing, all of that being done in a very thermal envelope that allows for it to not have a heat sink. And it's all a spiral effect after that. If you have a clunky processor with a heat sink, more it makes it heavy, so now you need a bigger battery, and it's on and on and on. So all of that goes away because we provide a very efficient, powerful processor that can handle it at all that temperature wise is very lucrative.
Well, you pack so much into a very tiny package for these autonomous operations. By the way, I also want to take a second and acknowledge a couple more people jumping in the chat. Shannon Knudsen from Parallel Flight Technologies is out there. He's not too far from you, Chad, I think. And Olga is saying good morning. Olga is one of our regulars. So awesome to have both of you out there, and everybody else. I know we're keep piling them on, so keep them coming. Keep telling us where you're from, and certainly ask some questions here, because when I say the actual platform is densely packed, so is the information that these two are going to be giving us here today. And Chad, on that note, I want to talk to you a little bit about kind of expand a little bit on these intelligent computer vision capabilities, which are so key to beyond visual line of sight flights and other operations and obstacle avoidance. So I know you and I have worked together on an article about the time of flight sensors and things like this, but can you explain how this intelligent computer vision is also packed into this very, very tiny package for your autonomous autopilot?
Yeah, absolutely. So as Deb was mentioning, it's a system on a chip. So there's maybe 20, 24 different individual processing units that are inside of this little package.
You're holding this up. Hold it up higher, and
sorry.
Put it in your palm of your hand as context, because I don't think people, put it in like the palm, or there you go. Like, to appreciate, I mean, that's maybe smaller than the length of your finger.
Yeah, it's
that is smaller than your thumbnail. So
it's the chip is smaller than your thumbnail. Holy shnikes. Yeah.
So yeah, and so but what's amazing about it is there's a lot going on in there, and they're all interconnected with shared memory and so forth. We'll try not to go up and get too technical, but on the computer vision side, one of the things we've done, in working with Qualcomm on this is to partition off certain workloads or certain tasks into different areas of the chip, which helps keep thermal down, which is important, but really disperse the processing so that the CPU is left for our customers' applications for them to go build on top of and achieve whatever those new use cases are, like indoor asset inspection, which I think is like has huge potential. And so but there's a lot going on. There's hardware for video encoding. There's just the straight encoding H.264, H.265, which this can do at 8K up to like 24 frames per second. And so the chip itself has all these different blocks that we want to take advantage of, or we do take advantage of and partition out. There's even on this chip a dedicated computer vision processor, which we're able to run like computer vision feature tracking and so forth and take advantage of that. So there's and I don't even know if we're halfway there on really opening it up.
It's really mind-blowing when you think of it. I mean, I think it was Dev, you held up your phone a second ago. I mean, this has become a part of our lives. We all just kind of, take for granted all the things that our phones can do. And you've packed all this into a super tiny package for drones and robots as well, including things like reliable connectivity to 5G. Isn't that right?
Yes.
Absolutely. Yeah. And so that was probably transitioning into the Qualcomm Flight RB5. That was something that Dave and I partnered on about 2 years ago and launched the world's first 5G drone. At least it was the world's first open kind of reference 5G drone, and it's still going strong today.
Yeah, I remember when that came out. I think we also have an image of that here. But so Dev, you mentioned this term, and I'm going to kind of jump onto it or pile onto it, no pun intended, because it's building blocks.
Yeah.
So tell us a little bit about how Qualcomm provides these building blocks for the drone and robotics industries to develop these next kind of best-in-class solutions.
Very good question. So I mean, the fact is, and to be honest, drone and robotics industry is not at a point where anybody can afford to make a custom chip for that application. So but the very interesting thing is that the processor that goes in the cell phone has all the components and all the building blocks that lend themselves beautifully to the applications like drone and robotics, because you need a lot of compute, you need a lot of perception, you need a lot of AI, and that innovation in Qualcomm is happening in different forms. We have a business unit focused on mobile phones, but we also have a business unit focused on automotive and autonomous driving. So all the technologies in Qualcomm, what we do is call it a one technology roadmap. That innovation is happening for mobile, and 5G is predominantly starting point for 5G. The first pillar is mobile. Then the IoT and robotics and other things like automotive come in. But the economies of scale at Qualcomm is because of our mothership, which is mobile and automotive. And I am blessed to be able to pick and leverage what is being built of billions of dollars of R&D on a year-on basis. On an average, we spend $5 billion in R&D. And that is what is fueling the innovation, because I am in the situation where I'm able to take the building blocks and build grounds up software like Linux, ROS, and prepare a platform such as the RB5 and give it out to the industry. And then Chad and the ecosystem takes it to the next level. So that's how it is even possible.
So you mentioned a bunch of acronyms in there. As a former military, hypersensitive that ROS. I only know about it just because I've been hanging out with Chad and some of these the coding crew lately. The robotics operating system is what you're talking about. We just talked about that on the full crew recently. RS2 is now out, but we had an image there of the Qualcomm Flight RB5 5G. It's a lot of letters and words. And so, not everybody out there, gentlemen, really understands what a dev drone is or a dev platform. Chad, can you just, Dev is talking about the building blocks, that Qualcomm brings to this development drone that was 5G. It was the first one. Explain to everybody what is a development drone? Like, why would they want to use that?
Yeah, so ModalAI and Qualcomm have a similar approach. I suppose a lot of us at ModalAI were at Qualcomm for like 20 years, so we borrowed some of the business techniques. But generally, ModalAI, we're trying to get as many folks as we can into our kind of core autopilot and computing platforms. And at Qualcomm, they're trying to get as many folks as they can onto their chipsets. And that's really hard, especially at the chipset level. If you're really hustling, it can be 9 months before your first PCB like this, you even have it up and booted.
PCB, I'm going to interrupt you. PCB,
like a printed circuit
board. Yeah. Okay.
So if you have your first, if you start with the chips and you got documentation and you got a bunch of data sheets and chips, here there's, I think there's about 500 components and 32,000 connections between the components. It's super complex, right? So you don't do this in a week and go out and fly. Just to get to this point alone, if you're really, really going, is a 9 month. It's really more realistically a 12-month process. And so you need something to start with, to go work on the technology, maybe work on your software, go test it out, maybe see what's going on. And so a big part of our business is actually taking that whole path all the way down to getting it to the smallest component. And so we have reference drones. And so on the Qualcomm Flight RB5, we worked with Qualcomm really, and also to highlight the 5G capability. And so there's still this demand. It's very interesting. There's a lot of cellular carriers that purchase those drones because they're looking for maybe a demonstration or a demonstration platform of some kind for 5G in the drones.
Like Dev wanted the same background as me, so he went dark. Yeah, so there he goes. I love that. It's just live when the lights
in the office keep going off. Sorry.
No, I was gonna say, it's live when the lights go out. You know what I'm saying? So that's so cool. I imagine it makes it so much faster of a process for example, an OEM, a manufacturer, when you already have these critical integrations ready to go. And, I think we have a really cool video of the Flight RB5 5G platform. So why don't we go ahead and roll that?
This is what it looks like when a premium robotics platform takes to the sky and brings with it amazing capabilities. Like cutting-edge AI for deep learning and autonomous flight, support for up to 7 concurrent cameras for high-resolution perception, long-range Wi-Fi 6 for communication between operators and other drones, low-latency 5G connectivity for remote, long-range, and beyond line-of-sight use, and a power-efficient compact design for smaller, lighter, and safer drones. Introducing the Qualcomm Flight RB5 5G platform, the world's first 5G and AI drone platform, offering powerful and efficient heterogeneous computing, designed to meet the various drone applications and use cases around the world. From aerial inspections of infrastructure, agriculture, and assets, to the filming of cinematic visuals for entertainment, to delivering packages and mission-critical tasks like first response. The Qualcomm Flight RB5 5G platform lays the foundation for your purpose-built drone and is designed to help your industry take flight. What will you do with it?
I love that. It's such a great video. One thing I want to highlight too, since we kind of glossed over it in the beginning, when we were talking about the things that enable autonomy, right? One of those is artificial intelligence. And we've been talking about this 5G piece of the pie, but can someone elaborate a little bit on the AI aspect of this?
Yeah, I think we both have a very similar approach in the sense that there's just this broad platform capability that is available in these chipsets. At least on the ModalAI role, is really to enable that to go accelerate our customers towards achieving those use cases. A lot of it comes down to object recognition. That's kind of the classic draw a box around something. Can be used for all sorts of things, whether follow me or a broad set of use cases, but the industry is like rapidly moving forward into utilizing those techniques for even what were classic geometric computer vision capabilities, certainly on like the filtering side of the processing of the data to make it cleaner, like depth maps and point clouds, making those cleaner and prettier and more regular versus kind of the noise you get. Each sensor has its own kind of noise characteristics. But I'll let Dev comment as well, because Qualcomm, actually my project at Qualcomm was actually born out of the original AI project at Qualcomm, and so I know that they've been focused on this topic since at least 2009, so at least 14 years. And the latest stuff that they've been putting out is insane in capability, especially for the thumbnail-sized chipset that doesn't require water cooling or liquid cooling.
All right, Dev, over to you.
Absolutely. So AI is one of the fundamental technology that Qualcomm is investing heavily in. And now, before AI was done using several building blocks, like you could do AI on a GPU, on a DSP, on a CPU. But over time, when AI has become much, much more important, and getting that throughput and also doing it much more efficiently warrants a subsystem by itself. So we are on our 5th generation of our AI subsystem in our processor. So just to have that anecdote, the Mars helicopter was before, when we had dedicated AI accelerator building block. We used to still do AI and computer vision using the other building blocks, but when it became very, very important and a lot more AI needs to be packed, now we have a dedicated processor on the chip, does 15 tera operations per second in the RB5 platform. And then our next generation is 10 times more than that. So AI is progressing very fast, and we are doing a lot of investment in keeping that on a silicon in a very efficient way as well. So that is going to help the entire drone industry and the robotics industry, because AI is very important for making quick decisions, perceiving objects, classifying objects, and perception just gets better and better with all of that.
Well, we're going to talk about your RB6 platform here in a second. But before we do, Dev, I want to acknowledge Matthew Borowski. By the way, Matthew, for those that don't know him, he's actually the program manager for the Defense Innovations Unit, Blue UAS Framework and Blue UAS Program. So his question is this. And by the way, I can't, I'd be very remiss not to mention that all of these products are DIU Blue certified, if you will. So Matthew's question is, Android OS and app development enabled a cell phone to move from a piece of hardware to an integral part of our daily lives. When will we see a similar software environment for people who interact with, not just develop, drones?
That's a good question. I mean, I think the classic version of that is the Skydio Follow Me, that they've done a wonderful job implementing. That would be maybe just probably the spark of what Matthew's getting at. It's tough. I mean, what's the, it took to get the computer going, a mouse, right? The mouse, and it took to get the phone going, a touch screen. I wonder what the UI interactive paradigm will be for drones. I think that's the thing that probably needs to be cracked open before the software paradigm really takes hold. I know people have done interesting stuff with motion control, but maybe that's not enough yet. You can certainly wave. We've done the wave at the drone and have it do certain things. I don't know if that's enough yet. I think that's maybe what's missing is what is the UI piece, the user experience piece that'll help drive that forward.
Yeah, I think you make some great points there, Chad. I actually have an AI camera now. And so, being Italian, I'm waving my hands and things flashing and then it freezes. It's so fun. interacting with that on a almost daily basis. But, I think the big difference, though, let's get out of the software side. I think the big difference with just the normal public interacting on a daily basis with drones in some respects, right, depends on what that interaction is, right? Because unlike a cell phone, you don't need a specific license to operate it. You don't have to register your cell phone. So I think, from kind of that no kidding operational standpoint, there's these extra things that will apply to drones. But from the aspect of me as a customer, I want this drone delivery deliver, I don't know, whatever package to my house. What does that look like in the future? I don't know, but it's going to be exciting to watch for sure. Thank you so much, Matthew, for that question. But Dev, I want to bring this back to your more current launch here at Qualcomm, this RB6 platform specifically. So tell us a little bit about this.
Yeah, so a couple of things, absolutely. One thing is, before this, we launched the RB5 5G platform, and just to say why 5G is important, right? 5G is important because we talked about autonomous drone, we talked about AI piece of it, but we all here from the drone industry know that the real future of drone and the potential of drone is going to get unlocked when the beyond visual line of sight happens.
Yep.
And for beyond visual line of sight, there are two things, right? One is you want to be able to operate beyond visual line of sight, so the drone needs to be able to communicate all the time. So it cannot be on Wi-Fi or anything. It has to be on cellular technology.
Right.
That's number one. And cellular, why would 4G not work? Because cellular technology is about, as it stands, was built for cellular phones, but 5G was the first technology that is built for things beyond phone, which is built for massive IoT and critical infrastructure and mission critical applications such as V2X, vehicle to vehicle, vehicle to infrastructure, drone to drone communication. So 5G is important for not only beyond visual line of sight, but also instilling the confidence with regulators and other bodies saying it's a very reliable technology. Now, taking that to the next level, RB6 and the platforms which will come in future are going to be being built on what we already have, like the RB5 5G platform. RB6 now adds tremendous horsepower, more AI capabilities, where we went from a 15 TOPS, again, TOPS is number, but in terms of throughput for AI, to almost like 80 to 100 TOPS kind of system in RB6. So as we go forward, the needs and the technology is going to evolve. The use cases are going to evolve. We are going to see drones being used for inspection, delivery, and all of that. So 5G is going to be important for those use cases. And AI is going to be important to make sure it's done in a safe way and an intelligent way. So both these technologies paired together are coming with the next level in RB6.
Well, that's awesome. And we're talking about technology and kind of the future. So let's pivot to that technology roadmap, not just for 2023, but beyond. And Chad, I'm going to bring this back to you because within the past, I don't know, several months, really, you've released the VOXL 2. So let's go ahead and roll that video.
Introducing VOXL 2, the smallest, smartest Blue UAS Framework autopilot at 16 grams. VOXL 2 is powered by the Qualcomm QRB5165 with an 8-core CPU, a 15 TOPS GPU and NPU, an integrated PX4 flight controller running on a dedicated DSP, and up to 7 concurrent imager inputs. Enable smaller, smarter, and safer drones and robots with VOXL 2. With an integrated AI powerhouse and flight controller, VOXL 2 runs more than 5 AI neural networks simultaneously. VOXL 2 helps the smallest, fully autonomous drones take flight. At only 16 grams and less than 10 watts, VOXL 2 is designed with the lowest swap for extreme AI computing. VOXL 2 enables the smartest drones, With clock-synchronized image sensors, VOXL 2 enables GPS-denied autonomy. VOXL 2 is assembled in the USA and NDAA 20 Section 848 compliant. Our open SDK supports thermal and low-light image sensors. VOXL 2 enables safer navigation with depth mapping for visual obstacle avoidance. Stay connected with popular point-to-point long-range radios, including MicroHard and Doodle Labs. And fly further with 4G and 5G for beyond visual line of sight. To learn more about VOXL 2, visit modalai.com/voxel-2.
All right, very cool. If you think that VOXL 2 is incredible, big reveal here, everybody, drum roll. ModalAI is now releasing the VOXL 2 Mini, so for even smaller, smarter, and safer drones. Look at this little thing. So we've got a slide up. Chad, just walk us through how if we thought that VOXL 2 was small, let's talk about the Mini. How does it compare?
Yeah, so thank you. So yeah, a bit of a sneak peek. We will be formally launching this in the next few weeks. We're very close. Obviously, I'm holding a live one in my hands. And so it's the same computing power, same computing platform, a little bit less IO, but 30% smaller. So the idea here was to fit this into even smaller platforms. It's now down to 11 grams. A total swap. It does lose some of the expandability. VOXL 2 had everything broken out, and whereas this one is a little bit more purpose-built, a little bit, with the presumption that if you're really trying to get to sub 200 gram UAVs, that you're not going to carry all the peripherals. But that's really what this is intended for, is 150 to 250 gram UAVs, indoor asset inspection being very compelling. Tiny cameras off performing ISR tasks. That's tiny flying cameras off performing ISR tasks. That's another one. Of course, swarm, which we think you're starting to see a number of things out there for swarm, and having these computing capabilities out there, being able to kind of co-process with a number of vehicles, a number of computers concurrently in the air. And so we also are doing our ESC Mini to go with this, which I'll try not to get too detailed, but basically between these two, you've got the full autopilot computing platform, computer vision processing, video encoding, video processing, and then the ESC speed control and power all integrated. And so this is 5.7 or 5.8 grams. So the whole thing for compute, autopilot, ESC, power, management, everything is just slightly less than VOXL 2 itself. So again, designed slightly different use case, same compute, same SDKs, same most of the capabilities, some IO limitations, most of the capabilities, but intended for even, achieving even smaller, more integrated, more compact UAV.
And fun fact, everybody, combined, this is still small as an Oreo cookie.
That's right.
If the other one was almost like a credit card or something, now we're talking cookie size or smaller. Hey, we're getting close to our time here, gentlemen, and we've got some great questions from the audience that I want to make sure we try to field before we go. So Paolo De Petra says, and I guess this one's for Chad, can you maybe elaborate on the choice of putting an ICM 4288 versus a better IMU like the BMI 270 on the VOXL 2? Is it cheaper? Is it easier to get?
Oh, that's pretty specific. The ICM 4268P is actually is very capable. It's a 32 kilohertz IMU with great noise profile, and we've had tremendous success with it. I don't know that we've compared it directly to the BMI 270, but we worked directly with TDK on the Qualcomm Flight RB5. And TDK has been a wonderful partner, so we carried that work forward onto VOXL 2. And the 4268P has performed very, very well for us. It's a very contemporary, reasonably new, was launched just 2 years ago or so. So we've had great success with it. No complaints at all, actually.
Awesome. And then Christopher Genesis is asking, are you guys tackling video transmission through cellular as well?
Absolutely, and I'm sure Dave will have more comments there as well. But yeah, we do that all the time. It's obviously it's different latency, different throughput than what you get with different radios, but they're all different for different use cases. The big advantage, of course, is that you don't ever run out of range. As long as there's a cellular network, you're connected and you have video. But I'll hand it to Deb.
Yeah, it's as equivalent as having a WhatsApp call over cellular from your phone. That's the same thing, right? We are using the same technology. Now, if you have a cellular connection, you're able to transmit the video over cellular on a controller or remotely over to IP addresses as well.
Well, the questions keep rolling in, gentlemen, and I'm having a hard time keeping up. Paolo had I guess a follow-on. So how many amps for the ESC?
Yeah, so we debate that. Now, why would you debate it? It's a little technical. The thing is, most of the specs out there that you see listed on, say, like an FPV component site are very ambitious. And so we tend to actually measure it and be really careful. So or accurate. And so we've gotten ourselves a little bit in trouble when we publish the specs as we measure, because, oh, well, so-and-so's advertising, a different number, and but these are very capable. We've been flying them with 5-inch propellers easily, and these are the same components that are in our larger ESC that fly 10-inch. I don't think we've validated that we've flown 10-inch, 2 kilogram, like 1 pound drones with this yet, but I think that's kind of the expectation, at least with airflow and so forth. So the amps, you have to be careful, because we actually measure those. I wouldn't even really call them competitive. Ours is very differentiated. There's a lot going on there. That it's a very efficient control mechanism. It's about 6 to 7% more efficient in flight time than BL Heli, and it's a digital communication between the ESC and the flight controller. It's a UART communication, so it's low latency, and we get feedback from the ESCs and bidirectional communication that way. So I'm hesitant to give a real amp number just because of the experience we've had, but the capability there, though, I think is there to fly, 8-10-inch quad rotors. We haven't validated that size yet with these, but we have on the smaller.
So we're talking a lot about weight, and this question is from Andrew Wilkins. I think he's referencing the VOXL 2 Mini. So the whole thing combined then is the same weight as the VOXL 2, or is it actually less?
Yeah, so I think it's slightly less. I think it's about 0.2 grams less between these two PCBs and then this one. Yeah, so I think this is oh, no, did I add that wrong? Maybe it's a little bit more. I think, yeah, this would be 16.8 and this would be 16. So they're about the same, but with a lot more, obviously. Well, it depends on how you mean a lot more capability, but this one this has the ESC and power included in this little stack up.
Okay, and then one more, and we're gonna give it back to these gentlemen for their concluding remarks here. We got Paolo asking one more question here. How's this different from any D shot?
Oh, the ESC protocol. So D shot's kind of a hack on top of PWM, whereas we're just using a straight digital UART. D shot is an attempt to convert PWM into a UART, and that's just legacy because a lot of folks had PWM connectivity between their flight controllers and their ESCs, and so it's kind of a natural progression without making people change anything, whereas we have just kind of your classic UART, which is also abundantly available.
Well, and this is a great segue, really, to encourage folks like Paolo and everybody out there. I know we've got a ton of live viewers, including Rotor Dynamics that just jumped up. Howdy from Greenville, South Carolina. to contact these gentlemen offline and have those conversations, especially if you're looking to, kind of improve your autonomous vehicles. These are the two you want to be talking to. So before I let you each have your kind of 30-second wrap up, I do want to ask you, are you going to be anywhere soon where people can see you in person? I know, Chad, you're not going to personally be able to make it to AUVSI Exponential, but your team will be there. Is that right?
Absolutely. Yeah, we have a booth. I wish I knew the booth number off the top of my head, but we do have a booth.
Yeah, so I don't know it either. I'm so sorry. Lauren is his taskmaster, and you can meet Lauren Young at my Law Tech Connect workshop. ModalAI is one of the sponsors, and Lauren will be on a panel about finding funds in the world for developing these kind of drones and robots, including federal different programs like Defense Innovation Unit that they've been so successful in their involvement in. So, all right. So you're not going to be there. Your team's going to be there. How about you, Dev?
Same thing here. I'm not sure yet, but my team is going to be there. So if I'm there, I'm definitely going to hang out at the ModalAI booth too.
All right. Well, I can understand why. I mean, they do have the coolest M&Ms, by the way. Fun fact: the best swag I think I've received for my event. They're little branded green and white M&Ms. So, all right, let's give it over to each of you. 30-second kind of concluding remarks, whatever you want to leave the audience with as we close out this episode. So I'll start with you, Chad, and then we'll end with Dev.
Sure. Yeah. Thank you, Don, Mike. It's been a great conversation. Deb, of course, thank you very, very much for joining. We're excited to get going on our, I don't know if it's our next generation platform, but an alternative platform here with VOXL 2 Mini, and we're going to continue to advance the industry towards smaller, smarter, and safer drones.
All right, and just on cue, there's the train you had mentioned, Chad. The lights go out, the train's going. Dev, over to you.
Yeah. So I leave this with this thought that be assured there's a lot cooking in the kitchen. We are making good new products, more technology coming out. One thing to take away is Qualcomm, or at least my team, I don't think there's any other semiconductor company that can tell you that we have a focused team building technology for drones and robotics. We have software, hardware, systems team looking at the right platforms to bring in for the drone ecosystem. And we have the right partners like ModalAI who take it and enhance it to the next level. So you can be assured that we are innovating, and the pace of innovation is what is warranted in the cell phone industry and automotive industries coming to the drones and robotics industry as well.
Well, absolutely. Everybody, that's a wrap. From the Earth all the way to Mars. These two are making it happen with smaller, smarter, safer drones and robots. So great to have you both. Thank you so much. Everybody, we are out here.
Thank you.
Thank you.